Good afternoon, ladies and gentlemen. I'd like to welcome you all to the first installment of CE3's 2013 Energy Webinar Series, hosted by Ohio University's Bottleneck School of Leadership and Public Affairs. My name is Scott Miller, and I'm the Director of the Consortium for Energy, Economics, and the Environment. Today's webinar, entitled Ohio's Transmission and Distribution Future, is made possible through a grant from the U.S. EPA to help Ohio facilities better understand their compliance obligations through their emissions reporting programs. The major grant activities for this project include workshops such as this one to inform Ohio industry on current trends in Ohio's energy markets and how changes to these markets may change emissions. Also under the grant, Ohio University will be augmenting an emissions database that we've created for the state of Ohio. Additional webinars and workshops are being planned for the coming months, so keep an eye out for information on those. In fact, later this week, we hope to announce a webinar related to lessons learned in the shale industry for the first week of May. Our events and our project work can be found through our website, www.ohio.edu/CE3. It's our intention to make the recording of this webinar available on this website very soon. An email will be sent to you when it is posted. I have several logistical responsibilities in opening up today's call, so first, I'd like to extend my thanks to our strong panel of speakers. We hope you enjoy the dialogue, and I feel sure that you will have something useful to take away from this meeting. If you have a question that you would like to submit to our panelists or our staff during the call, we ask that you use the question field in the GoToWebinar navigation pane to type in a question for our panelists. This will allow our moderator to choose from the questions you submit to help stimulate conversation after the presentations have concluded. We will try to get as many questions answered as possible during our time together today. Finally, at the end of today's call, our moderator will ask you to fill out a brief online evaluation of today's webinar. A link to the evaluation will be emailed to you after the call. Please take a few minutes to provide us with the feedback of today's session so that we can learn how to improve for the future. We've incorporated many previous suggestions into today's webinar. And with that, I believe I've covered all of my logistical bases. It's now my pleasure to introduce my colleague and our moderator for today's webinar, Michael Zimmer. Mike is the Bottleneck School's Executive in Residence for Energy, Economics, and the Environment, a capacity in which he has served for almost 7 years. Mike has extensive experience, including over 30 years in the energy field, and has a strong understanding of the interplay between our changing energy systems and greenhouse gas emissions. Mike is an expert on energy policy and a practicing attorney who is focused on energy project development and financing. Here at the Bottleneck School, Mike is an integral member of our energy and environmental leadership team, a contributor to our recently completed report for the state of Ohio entitled Assuring Ohio's Competitiveness in a Carbon-Constrained World, where we studied the impact that federal climate change legislation would have on Ohio's economy. And he has written numerous white papers, blog posts, and long-form essays, many of which you can find on our website. With that, I'm going to step out of the way and turn this webinar over to Mike. Mike, please take it away.
Thank you, Scott, and good afternoon to our audience in the state of Ohio as well as nationwide. It's my pleasure to welcome our distinguished panelists today who will share their thoughts and insights on our topic, Ohio's transmission and distribution future. Our first speaker is Dr. Benjamin Schlesinger, the founding president of Benjamin Schlesinger and Associates here in Bethesda, Maryland, outside of Washington, D.C. Ben is one of North America's leading independent energy consultants who specializes in gas and electricity marketing, pricing, infrastructure, trading practices, strategic planning, and fuel planning for power facilities worldwide. Dr. Schlesinger has advised over 500 clients in the United States and Canada, as well as in 25 other countries. Dr. Schlesinger is a former vice president of the American Gas Association and a member of the New York Mercantile Exchange's Natural Gas Advisory Committee. He's also served in 2011 as president of the U.S. Association for Energy Economics and as a member of the Brookings Institution Natural Gas Task Force. Our speaker that will follow after Dr. Schlesinger, we're pleased to welcome Chairman Todd A. Sniffler, the chairman of the Public Utilities Commission of Ohio, who was appointed to that position by Governor John Kasich in March 2011. Chairman Sniffler serves as chairman of the PUCO, heading a 350-person agency that works to oversee the regulation of electric, natural gas, telecommunications, water, and commercial transportation in the state of Ohio. He also serves as the chairman of the Ohio Power Siting Board that reviews, evaluates, and approves the siting of electric generation plants and electric and natural gas transmission lines. Chairman Sniffler is also a member of the NARUC and serves as co-vice chair of the NARUC Committee on Gas. Before joining the commission, Chairman Sniffler was elected to 2 terms in the Ohio House of Representatives, where he represented the 50th House District, including parts of Stark County. Prior to his service in the legislature, Chairman Sniffler was also an attorney in private practice and is a member of the Grove City College Alumni Council. Our final panelist today to share his unique insights and perspectives is Pablo A. Vegas, the President and Chief Operating Officer of AEP Ohio. Pablo serves in this capacity with AEP Ohio, which serves 1.4 million customers in the state and the northern West Virginia Panhandle. Previously, Pablo served as Vice President and Chief Information Officer for AEP, responsible for the development and support of AEP's software applications and the operation of AEP's information technology infrastructure. From 2008 to 2010, Pablo served as President and Chief Operating Officer for AEP in Texas, overseeing distribution operations in the Lone Star State, serving more than 900,000 AEP customers in Central and North Texas. Before joining AEP, Pablo held several senior leadership positions with IBM, PricewaterhouseCoopers, and Anderson Consulting. With those introductions, I'm pleased to turn the chair over for our first presentation by Dr. Ben Schlesinger. Ben, the floor is yours.
Good afternoon. Thank you so much, Mike. It's great to work with you, and it's great to be a part of this very distinguished panel. What I would like to do is take a couple of minutes and lead off the webinar with some general thoughts on shale, gas, and oil lately, increasingly. Demand for gas, the demand shortage, some of the demand possibilities, and some of the challenges that all this connotes. It's a little bit about our firm. I think, Mike, thank you so much for your kind introduction. I think you basically hit on all these points. So what we've really got is an enormous resource base, which we always knew we had, but now we've got the technology to go in and get shale gas economically. And that really extends to coal bed methane and other forms of unconventional gas, tight sands, and and others are all kind of now being produced at very low cost. I think if I can just sort of make one point and nothing else, it's to just kind of express what a mental block I think most people have toward shale gas in terms of the volume. When you see a run-up in production for anything that's any curve that goes up as quickly as the one here on the left, I guess you can all see this is the increase in gas production from shale in the United States. Anytime something increased by a factor of 10 in just a couple of years, 5 in very few years, kind of passes most people by, and it's hard to kind of get a grip on it. Most people really don't have a sense of how much this really amounts to. In the next slide, you can get a sense for this. The U.S. is just from the increase in shale production, apart from shale gas that we're producing 10 years ago, and apart from many other production the United States has for natural gas. we're producing from the increase in shale twice as much gas as Qatar is producing, nearly twice as much. And Qatar is the largest exporter of liquefied natural gas in the world. We're producing more than twice as much as Norway. If you look on the oil side, you see that we're producing from just our shale gas almost twice as much energy as Venezuela is exporting or producing totally, including their exports in the form of oil. And we're getting close to half of Saudi Arabia, just the shale gas itself. And of course, we're now producing another 2 million barrels a day on top of shale gas in the form of oil. So these are enormous numbers, and I think people haven't really wrapped their heads around what an enormous producer the U.S. is. We're hearing phrases like Saudi America coming out of the International Energy Agency. They're not kidding. What we have, though, is a disparity that has really set in the field. The chart on the left is a little complex. It shows the price of crude divided by the price of gas. That's the blue line. And the same price of crude divided by the price of gas in the future based on NYMEX futures. Then on the lower part of the graph, it's the number of rigs drilling for crude divided by the number of rigs drilling for gas. That's the green line. As you can see, the rigs looking for oil follow, the ratio of rigs looking for oil versus gas follows the ratio of oil versus gas price. We've seen an enormous increase in oil prices and an enormous decrease in gas prices, and as a result, the rigs have left gas, they go for oil. This means rigs pull out of the Marcellus and look for gas in Ohio's Utica Formation, and more particularly Eagle Ford in Texas and Bakken in North Dakota. Rigs are free to move. This is a free country, and they'll move back when prices for gas increase, and they'll move out when prices elsewhere look good. So we've got in futures markets about a 3-to-1 price ratio that things will hedge. It's about 4-to-1 right now. So I think for the time being we're going to continue to see the search for oil, not the search for gas. And oil production is increasing right now in the same dramatic rate of increase that gas did just a few years ago. We see some technology adaptation to oil, not just multi-well and multi-stage fracking, which really gave rise to the gas production increase. But also we're seeing more and more of a need to recycle return waters. When you do that, and the reasons because South Texas and western North Dakota are fairly dry regions where most of this new oil, tight oil, is coming from. You've got to recycle the return waters. You can't just keep throwing more water down the hole and forgetting about it. When you recycle return waters, as some producers have begun to do, this really eliminates pathways to the groundwater, which is interesting. You also have some new possible techniques. Dry fracking is being tested in some regions. And there are challenges. The low gas and low liquefied, NGL, it's natural gas liquids, which is propane, butane, ethane, and so forth. These low prices tend to be self-correcting. As we peak in gas production in the United States and start to decline because of the lack of drilling, we'll see prices rise regardless of what we do. It isn't a matter of using more gas, therefore the price goes up. It's failing to use gas when you have a long, flat supply curve of the kind that we have that will raise prices. I think we also have some significant pipeline bottleneck issues, particularly in the Bakken. We're seeing gas flaring. The high cost of rail, failure to build pipelines, or delays in building pipelines is a real effect, as well as some environmental issues in moving product around by rail, and eventually skilled labor shortages as more of the action goes abroad. So looking at the surplus, where's the surplus of gas going? Clearly in the Midwest, it's going to replace coal in old power plants, most coal-fired power plants in coal country, which I've defined here in this analysis as 20 Northeast and Midwest states, really centered in and around Ohio, plus Ontario. these power plants are aging, and they are going to be have to be retired and will be replaced by gas and probably by wind as well. To the extent these plants are replaced by natural gas, the carbon emission reduction is enormous. It's about 2/3 or so. We've heard figures like 50% reduction in carbon when you switch from coal to gas. That's not actually the case. It's actually much bigger than that, because you've got two effects working together. There's a chemical advantage to burning gas versus coal in terms of all environmental, let alone carbon. And you have an efficiency advantage. It takes less gas to reach the same megawatts. It's kind of unfair. We're competing brand new high efficiency gas-fired power plants versus old, 50-year-old coal-fired boilers. But that's the reality. So chemical and efficiency both put together is well over a 50% advantage. Of course, you've got other criteria emissions as well. The thing is, the low-hanging fruit is being picked. There's only so much of a wealth of old coal plants that can be replaced before you start running into some pipeline bottlenecks for gas, such as we have in Maryland, and other issues. The efficiencies of some newer coal-fired power plants is really not too bad, as they found in Texas. Anyway, for the time being, this is where the demand is likely to go. I think the other, some other exciting sources of gas demand, certainly natural gas vehicles. Shown here is a truck that uses liquefied natural gas and can go with one tank about 400 miles, two tanks 800 miles. Petrochemical plants. Every day I pick up the paper and see another plant that's being located by either a foreign company or U.S. company in the U.S. to take advantage of low gas prices. And this, I understand there are over 100 of these that have been proposed. Many of these are in the southwest area of Louisiana, Texas, in the middle of those shale fields, but we're going to see these in Ohio as well. There's no question about it. And you probably are more aware than I am of some of the increases. And of course, there'll be some export to some limited degree of liquefied natural gas to countries abroad, such as Japan. So looking in, in this region, we're going to need in and around Ohio more natural gas facilities. That means pipelines, storage, and gas distribution systems. That's the low pressure lines needed to bring gas directly to users. In some cases, this is simple fixes. In some cases, compression, and so in some cases it does not require major new infrastructure, but in other cases it may require new gas facilities. Plus, there's some new sites for these facilities that require some delivery, for a gas delivery system increases. With respect to gas for power generation, there are special coordination issues that I know, Todd, and, Pablo have been looking at, and Mike, and we'll be speaking about these, in the next couple of minutes in this webinar, I'm sure. From our experience, we see significant issues arise when their supply and demand geography varies. The gas may be coming from eastern Ohio, and some new plants may be in western Ohio, for example. We see pipeline dispatch timing issues constantly arise, especially where electricity's got to be produced on demand, either in peakers or intermediate load plants. And even if a pipe's in place, it's still got to be dispatched in a fairly rigid way, unless there were LNG, which is a liquid. In some places, new power plants are located right next to LNG tanks, so the gas can be LNG can be gasified and put right into the power plant without any delay and with no uncertainty. It's not necessarily that case. So pipelines have to be dispatched. It's now noon. Tomorrow's dispatch has already been sent in, request for gas service. And for example, wind can be rise and fall 4 times in a day. So these are just a kind of a handful of the issues. Maybe there's a need for a council patterned after the Electricity Reliability Council. And I understand Mayor has had some discussions along that line. So this is kind of an overview to the issue. I'm going to be here, and we can talk about these. And but right now, I think what I'd like to do is pass it back to you, Mike, to introduce Todd, which I think you already have, or I'll just sort of cede the floor at this point and take people have any questions. Thank you so much.
Ben, thank you for setting the stage for our discussion this afternoon. We're pleased to welcome our next speaker, Chairman Todd Sniffler, Chairman of the Public Utilities Commission of Ohio, who will share with us his insights both from within the state as well as his national work with NARUC on the current state and future of Ohio's infrastructure and generation portfolio. Welcome, Todd, and the floor is now yours.
Todd, I believe you may have your speaker on mute currently.
I think I may still be on your mic system.
Does that work?
There we are.
Can you hear me now?
Yes, Todd, thank you.
Good. I feel like I'm in a Verizon commercial. I apologize for the delay in getting started. Again, I think we can follow up very nicely on Ben's comments, and certainly appreciate the opportunity to provide my insight and some general thoughts, and look forward to the questions that may come as a result of this. Mike, certainly appreciate the introduction and the very kind words that you had to kind of lay things out, and I think it's always important for us as we look at where we start. The Public Utilities Commission here in Ohio affects every household in the state, and that's because we oversee the public utility industries, including gas, electric, local landline telephone, water, railroad, hazardous material carriers, and commercial motor carriers. And the Commission was created to assure Ohioans adequate, safe, and reliable public utility services at a fair price. And our agency is the only one charged with enforcing the laws that the legislature enacts regarding regulated utilities. And so as we look at the next slide, I think it's important for us to set the context for where Ohio is. And that's with the result of the passage of Senate Bill 3 in 1999 and then the update of Senate Bill 221 in 2008, some dramatic changes were made to energy pricing and energy sourcing within the state of Ohio. And I think the major components of the legislation required electric utilities to separate their generation and distribution services. And in 2008, with the adoption of Senate Bill 221, we furthered Ohio's electric restructuring and created an alternative energy portfolio standard. And a major component of that is the yearly minimum renewable energy benchmarks that require utility companies to derive 25% of their electric supply from alternative energy sources by 2025. And specifically, half of that 25% can be generated from advanced energy, but at least half must be generated from renewable energy sources, with at least half of 1% coming from solar, and half of that is required to be produced in-state. If you could advance to slide 3 for me, please. Renewable energy resources are defined in the code to include such things as the ones you'd expect: solar, wind, hydro, geothermal, biomass, abandoned coal mine methane, and as a result of last year's passage of Senate Bill 315, waste energy recovery systems. And nearly 1 billion megawatt hours of renewable energy production was utilized in Ohio during 2009 and 2010. As Ohio's public utilities explore the different methods they have to comply with benchmarks and the standards that are set forth in 221, especially those pertaining to renewable sources of energy, we're at the Commission are closely monitoring the proposed legislation as we measure and quantify the outcomes that have already occurred. Since 2008, wind power developers in the state have actively moved several wind farm projects forward, and 2 of those projects are operational: the Blue Creek Wind Farm in Van Wert and Paulding counties, and the Timber Road project that's in Paulding County. The 2 projects consist of 222 total turbines with a combined generating capacity of nearly 450 megawatts of electricity. Additionally, there are several other projects that have received certification from the Ohio Power Siting Board and are awaiting construction, and these include Buckeye Wind 1 in Champaign County, the Hog Creek and Hardin Wind Farms in Hardin County, and Black Fork Wind Farm in Crawford and Richland counties. And Buckeye 2 is in Champaign County, and it is currently in the midst of its siting process. If we can advance to the 4th slide, there's several things that have caused wind power momentum here in Ohio and around the country, such as the federal production tax credit, the state renewable portfolio standards, technological improvements, price volatility that we're facing with other fuels, additional interest in clean energy sources, climate change, and energy independence. And we've found that the wind farms in Ohio help provide the necessary renewable resources that allow the utilities to meet the energy portfolio standard. But we also have regulations here that enable a retail customer to own small wind and solar installations and use those as a renewable resource to offset their own electric usage and demand and potentially earn a credit for net metering on their electric bill. That's not to say that integrating wind has been easy. If you can advance to slide 5, siting of wind turbines has been contentious, and getting the necessary financing is difficult, as it is for most capital-intensive investments. There's certainly plenty of concern with the intermittent nature of the resource, implications on the grid, and the potential need for backup generation, but I think we're on the right track for a healthy mix in the state. We have a lot of solar that's been added to the system, which can help offset the wind resource, which tends to be plentiful at night, and we're looking at new and additional gas resources, which I'll touch on in a little bit. And if you can advance the slides, the Commission has a process for a facility seeking voluntary certification as Ohio Renewable Energy Resources, or a generating facility under the state's Alternative Energy Portfolio Standard, and that allows the renewable facilities to create renewable energy credits, or REC credits. Since the inception of the program, the Commission has certified more than 5,600 renewable energy facilities, which total approximately 3,900 megawatts of combined renewable energy capacity. So we not only have wind and solar, but also solid waste, hydro, abandoned coal mine methane, and the assortment of biomass and biogas applications, some co-firing, and even a fuel cell that have been approved. So again, it's a healthy mix of technologies commensurate with the capabilities of those technologies. And the advanced energy resources may include clean coal technologies, advanced nuclear, cogen facilities, demand-side management, and energy efficiency. Advanced energy could be any new, retrofitted, refueled, or repowered generating facility located in Ohio, including a simpler combined cycle natural gas generating facility, or a generating facility that uses clean coal technology, modular nukes, or any other fuel as its input. And I think it's fair to say at this point it's common knowledge that our energy potential due to the Utica Shale play is a game changer for the state's economy. The Kasich administration is firmly committed to take full advantage of our domestic natural resources so that all Ohioans share in the benefits that fully realize our energy potential and what that will bring to the state. Most importantly, the abundant amounts of natural gas have reduced commodity prices, both here and as a result of the Marcellus to our neighbor to the east, Pennsylvania, which is already allowing consumers to realize significant cost savings on home heating costs as well as industrial uses, including fuel for generating electricity. And in order for Ohio to maximize the benefits from the additional oil and gas drilling, efficient infrastructure is a key. So far, there have been more than 575 drilling permits issued by the Ohio Department of Natural Resources for the Utica Shale. Upgrades and expansions of existing pipeline infrastructure are therefore necessary to move the commodity to market, and you've probably seen recent news stories to that effect. New midstream infrastructure, otherwise referred to as gathering lines, are critical in moving shale products from the wellhead to processing and fractionation facilities that will refine the raw products to become market-ready, and robust delivery systems are needed to deliver gas to end-use customers. The Commission's been working with a number of stakeholders to streamline the regulatory process and ensure prudent safety measures in place. Our principal goal is to minimize regulatory barriers, but ensure the safety of all Ohioans. And I've been pleased with the many programs that several companies have already undertaken to restore, replace aging or inadequate infrastructure, and these programs have already benefited both residential and business customers in Ohio, and we applaud the companies' efforts to upgrade their delivery systems to provide optimal service to their customers. Furthermore, doing so provides several opportunities for us to utilize waste energy recovery technologies that reduce pressure in pipelines before the gas is distributed through them in order to convert that reduction in pressure to generate electricity without any additional fuel source necessary. So I think innovation is yet again being pursued, and that's a good outcome for Ohio. Another core strategy being analyzed in Ohio is switching fuel sources for some power plants from coal to natural gas, due both to the natural gas price and environmental regulations. As I'm sure many of you are aware, there are a multitude of rules and directives being issued by the U.S. EPA with the desired goal of reducing fossil fuel emissions and thus our carbon footprint. Ohio, however, is the traditional producer of fossil fuels, whether it's coal, oil, or gas, and the extraction and use of each of those has played a major historical role in our economy. And fossil fuels will continue to play a major role in Ohio going forward. For this reason, as chairman of the commission, I've communicated to federal policymakers at every opportunity through congressional testimony, submitting comments to FERC, or in my role as the NARUC vice chair of the gas committee, the consequences that the attack on coal could have on our economy. And if we can take one positive away from the current situation, I think this is the opportunity for natural gas to step up and play a much larger role in our state's power generation sector. There are currently 2 natural gas-fired generation cases pending before the Ohio Power Siting Board. One is an amendment for an existing simple cycle plant to convert it from approximately 870 megawatts to more than 1,400 megawatts, operating at intermediate or baseload mode. And the second application is to construct a brand new generation facility for almost 800 megawatts of utilizing advanced gas turbine, steam turbine technology. To be clear, Ohio needs a balanced approach where coal, natural gas, and other cost-effective resources can peacefully coexist, so we do not become overly reliant on any one source. Being overly reliant would leave us vulnerable to rapid price fluctuations due to changes in commodity price, and that's bad for consumers. In 2010, 65% of the installed capacity was coal generating, and it generated approximately 80% of Ohio's electricity. New CARE, Mercury Air Toxic Standard, the MATS, or the Boiler Act, and other rules that the U.S. EPA has implemented over the past few years have led Ohio power generators to plan 6.2 gigawatts of retirements between now and 2015, and the last report I saw indicated 44.2 gigawatts nationally, with more generating units expected to be slated for retirements beyond that time period. This could result in almost a 20% reduction in installed capacity of coal generation in Ohio. As a result, in order to maintain that safe, reliable, affordable power for Ohio consumers, we at the Commission and our utilities and providers must actively pursue all resource possibilities to ensure we have a strong and diverse domestic generation fleet. And this is where switching from coal to natural gas-fired generation comes into play as a viable alternative for achieving that goal. While this transition can't and won't be made overnight, I believe it's crucial for us to begin planning for such a move, as it will only become costlier and tougher to do so if we drag our feet. And I can report that that is already being undertaken, and we're pleased thus far with what we're seeing. By utilizing more natural gas, our generation fleet will become cleaner and more efficient, which will assist us in achieving emissions attainment levels. And with the recent discovery of the reserves that are trapped in the Utica Shale, it seems that a serendipitous turn of events that could go a long way to ease our transition, and it's something that we're working to take advantage of immediately. As we move forward in a timely and efficient manner, however, work has got to be done by state and federal regulators to accommodate this transition to gas in the harmonization of gas and electric industries. And to that end, I'm thankful that FERC has taken the lead on the issue, and I've had the pleasure to advocate for better alignment between natural gas and electric markets in order to more fully maximize the benefits from the country's shale plays. Just 2 weeks ago, I provided testimony to the U.S. House Energy and Commerce Committee on this very issue. Using natural gas for electric generation just makes sense, plain and simple. It's abundant, it's readily accessible, it's cheap, and it emits fewer greenhouse gases than other conventional sources, making it a better choice for the environment. Several issues, however, still need to be addressed, and first and foremost is improved communication, and that's needed at all levels between industries. Certain restrictions on what information can be shared, which under the traditional model are logical to protect confidential information and comply with corporate separation, pose barriers to effectively meeting reliability standards with new gas generators. There's also concern regarding the supply of natural gas and the ability to secure sufficient amounts of power generation when it's needed. An important question is this: if an electric utility signs a long-term contract, which at the time of execution is reasonable, will the utility be denied full cost recovery due to what we would call Monday morning quarterbacking decisions if market conditions change during the contract period, or will the prudency test be applied at the time the contract is entered into? In addition, it may be economically difficult for electric generators to commit to firm contracts when expectations of running times may be quite low, and that is the gas units may only run during peak times. And so those are issues that are going to have to be fully vetted and developed as we move forward. The last issue that we need to address for better market coordination between gas and electric markets is that the markets have simply developed differently, and the businesses operate under entirely different structures. The electric grid, of course, is designed to serve peak demand for all customers in the region, and the gas pipeline systems are individually designed to serve the demands of customers with firm contracts on a pipeline-by-pipeline basis. And this returns us to our firm contracts question that I posed a moment ago, because without firm supply and delivery contracts, there is no requirement for the pipeline company to deliver the gas commodity. The other issue is that commitment timing, both for generation dispatch and pipeline capacity, is not synchronous and therefore could result in supply shortages at a time when gas is most needed, and Ben already touched on that. Incompatible schedules could also result in substantial impacts on availability of energy supply and system reliability, most likely during times of increased demand by electric utility customers. And as I mentioned before, our number one goal is, of course, to ensure ready access and system reliability for customers. Failure to improve the interrelationship between the two industries is likely to lead to poor outcomes for end users and greater pressure on both utilities and regulators. By better harmonizing the industries, we can secure benefits for both utilities and consumers, ensure better operation of the grid, and improve system reliability during a period of fuel switching, ultimately providing stability to all markets. If I can switch gears for just a moment, I'd like to address another important topic that we're dealing with, and that's cybersecurity. With the continuing rollout of advanced communication technologies in both electric and natural gas industries, cybersecurity is a hot-button issue for consumers and industry alike. And recently we've seen headlines in the news such as the Department of Homeland Security report where 40% of cyber attacks targeted the energy sector, that a water utility was hit by a decoy attack, a cyber attack leaving natural gas pipelines vulnerable to sabotage, cyber threats to the energy sector happening at an alarming rate, and a malicious virus that shuttered a U.S. power plant are just some of the headlines we've seen most recently. And cybersecurity isn't about stopping the bad guys. Vulnerabilities to our energy systems include software bugs, user errors, control system equipment malfunctions, communication equipment failures, and others. The biggest concern and threat, however, is the deliberate intrusion and sabotage. And according to the fiscal year 2012 ICS CERT data report, of industries experiencing cyber attack threats, 41% are on the energy sector, and second to that is water at 15%. And recently we've seen increasing threats from spam, phishing, and malware, as well as threats from Stuxnet, Dooku, and a number of other attacks from various countries and various parts around the world. And these threats come from all over the globe, including script kiddies, also known as basement hackers, the criminal element, and from aircraft carrier nation states. And the key to successful cybersecurity structure and culture is the development of an effective and robust partnership between public and private sectors. And these efforts must meet current needs while also being flexible enough to address an ever-evolving threat. States can have a large impact on ensuring communication between utilities and the Department of Homeland Security and the FBI are open and resourceful. Public utility commissions are at the forefront of developing guidelines for cost recovery, handling sensitive information, and the sharing of that information, reviewing utility emergency response plans, oversight of system reliability and regional coordination, as well as setting up and updating state emergency planning efforts. Currently, several states have opened up dialogues with their state utilities, including setting up guidelines and implementing protocols regarding cybersecurity. For example, the Missouri and Pennsylvania Public Utilities Commissions, as well as here in Ohio, have opened dialogues with our utilities within our states to discuss measures and procedures to better ensure security of our energy networks. In Connecticut and Texas, their public utility commissions have taken cybersecurity measures a step further with implementation of smart grid and SGIP-CS. In Ohio, we have great partners who fully recognize the major threats our utilities face and are prioritizing cybersecurity. As chairman here at the Commission, I've taken on the task of meeting with all of Ohio's investor-owned electric utilities to better understand their efforts to protect information and facilities from cyber threats, and I plan to have the same conversations with Ohio's natural gas utilities. At the Commission, we have an expert on staff who serves as the chair of the National Association of the NARUC Staff Subcommittee on Critical Infrastructure, a committee that is largely focused on cybersecurity. And if you've listened to the NARUC president this year, Phil Jones from Washington, this is a top priority for him. Additionally, Congressman Bob Latta and Congressman Steve Stivers, as well as our two U.S. Senators, Rob Portman and Sherrod Brown, recognize the ever-increasing need to proactively protect our utilities from cyber attacks. Covering a large swath of topics today, I'd like to thank you for inviting me to speak on these matters that are very important both to me and to the Commission, and these are matters that affect every Ohioan every day. So as I say every time I speak, we have an open door here at the Commission, so after our conversations today, if there are other questions that come up, please don't hesitate to contact me at your convenience. And with that, Mike, I'll turn it back to you.
Thank you, Chairman Sniffler, for a very comprehensive and thoughtful presentation and sharing your thoughts and insights with our audience. Our audience is reminded, please submit any questions that you may have for our panelists today using your GoToWebinar navigation pane. I'm pleased to welcome our final panelist today, Pablo Vegas, President and COO of AEP Ohio, who will share with us his views on the electric distribution system, the challenges today, and looking ahead as well to the future. Pablo, thank you, and the floor is now yours.
Thank you very much, Michael. Can everybody hear me okay?
Very good.
Yes, just fine.
All right. Wonderful. Thanks for that handoff and that introduction. We have some great topics being teed up by both Ben and Chairman Sniffler, so looking forward to getting to some of the Q&A that will likely follow this. Today I'm going to talk a little bit about another part of the distribution infrastructure, which is of the utility infrastructure, which is the distribution system. And the topics I was going to focus on today, we'll talk a little bit about today's distribution system on a macro level, what the distribution system of the future might look like, and then go into some specifics about what AEP Ohio has done with regard to what we call the Grid Smart program, and that's a fairly broad technology investment in the distribution infrastructure, and looks at a lot of different types of technologies, both customer-facing as well as utility-facing. So why don't we go ahead to slide 3, give a little bit of perspective on the way AEP looks at the distribution system. We have one of the largest systems in the United States with over 222,000 miles of distribution lines, the large majority of which are overhead lines. We're serving a very large customer count, about 5.25 million customers across 11 states, and being served by 7 different utility companies, of which AEP Ohio is one of those. A large volume of assets, millions of poles and transformers and cutouts and all the pieces and parts that take electricity through to your homes and businesses. It's a significant volume of assets to maintain and take care of. And then when you look at the value of this investment, when you consider AEP, I look at AEP really as a representative utility of what the entire nation's infrastructure would look like. We have a very broad geography and serve a wide swath of customers, so it's fair to assume that it's a relatively fair representation of the distribution system overall. And you can see that the net book value of these assets, nearly $10 billion, while sizable in and of itself, a good portion of what's active and out in the system has already been depreciated past its book life. Now, the book life for a distribution asset could range, from 30 to 40 years, and the actual life of it could actually go longer than that, 40 to 50 years. So when you consider that, when you look at the amount of infrastructure that's out carrying electricity into our homes and into our businesses, you can see that there's a lot of infrastructure that needs to be maintained, and there's a lot of old infrastructure out there that has challenges. The last point, is a relatively new point, and a new circumstance change in that equipment failures now are one of the leading causes of outages across our system, taking the place of weather-related events. And so, again, points to a unique challenge that we as a company face, and I think that the nation overall faces in terms of maintaining an adequate and reliable distribution infrastructure. So let's go on to the next slide. So as we think about the distribution system of the future, I think there's several questions that need to be considered, and one that utilities across all of the U.S. are considering, that AEP are as well. And the first one in particular, if you look at that, what strategic investments in smart grid prepare us for the future and prepare us for, what the use of the electric system needs to be. Now, when we think about, the smart grid considerations, smart grid has been a coined term that I think has been used now for quite a long time, and was always kind of looked at, okay, as the next innovation or the next cutting edge technology that goes into the distribution system, but it's different and separate from kind of the core utility infrastructure that's out there. And right now, the way we look at the smart grid of the future is not really separately or differently than the way you would look at your regular distribution infrastructure and the maintenance of it. Having smart components in it is now one of the key elements of the distribution infrastructure. And so the question is more about at what pace are you going to go out and invest in that infrastructure, and how much replacement are you going to do, and how much, how close to the leading edge of technology are you willing to go in order to get some of the benefits that are offered. Another key question that we deal with and that all utility companies deal with is looking at the role of federal legislation as well as state regulation about how investments in the infrastructure is made. Right now there's a lot of active discussions, as Chairman Sniffler mentioned, regarding cybersecurity. The federal government is contemplating several ways of addressing cybersecurity on a federal national level. And most of the discussions that affect the distribution infrastructure occur more at a state level rather than at the federal level. As an example, many states right now are contemplating regulation and legislation both specific to storm response and hardening of the infrastructure in response to some of the significant weather events that the country experienced last year, Superstorm Sandy being one of those, and many other strong weather events that took place last year. In addition, there's a lot of specific legislation that's being contemplated. In Ohio specifically is looking at the legislation that deals with state mandate for renewable power and energy efficiency, which, again, Chairman Sniffler did a nice job of explaining how those mandates go into effect and are working today. And while you may look at some of those type topics and say, well, how is that specifically related to distribution infrastructure? Those are more supply. They all have an effect on the business model and the economics of managing the full energy infrastructure, which includes the generation, the transmission, and the distribution as well. Another key consideration in the thinking about smart grid is that its potential to affect reliability. And so through self-diagnosing, through distribution automation of control that allows power flows to self-direct around system faults, the question then comes, how much value can you place on improvements to reliability? And how much investment are you willing to make in order to affect that? There's not a question of whether smart grid components can improve reliability. The question is how much are we willing to spend and what kind of an impact are we going to be able to have on reliability? I want to go ahead and move to the next slide. What I've teed up with this next slide is just a simple visual to kind of give a perspective on how today's distribution system looks and works, where you have, at the top your electric power supply, taking the electricity that's generated and stepping it up into call it the inter or intrastate transmission system, where you have the very high voltage transmission lines up to 765,000 volts here in the United States. And then that transforms it down as you get closer to the load distribution centers. You start stepping that down to 34,000 to 138,000 volts in that range. And then when you get into the communities, into the cities that are going to be served by this power, you're going to step that down once again into the distribution system and move that down in the 12,000 to 34,000 voltage range, all the way to the point you get to a business or a residential user. And one of the key attributes of this distribution system today, as you look at it, is that as you get closer to the customer, the amount of information that we, the utility, have around that power that is being distributed gets less and less. So if there's issues with the system on the distribution grid, it often takes a call directly from a customer or a visual observation to understand the source of that problem. So let's move on to the next slide. So what are some of those challenges with the distribution system today? So one of the ones I just mentioned, obviously, is that we do not know what the status is of the grid. So we don't know specifically, unless you are a customer that already has a smart meter, we do not know whether power is on at your premise unless we are notified by you directly. And we also have very little intelligence on the line devices themselves, the regulators, the reclosers, and the equipment that help to direct the power flows throughout the grid. We get very little information from those electromechanical devices as they have been designed for the last many decades. In addition, in the operation of the distribution system, it's a fairly manually intensive operation. And so diagnosing faults or doing circuit switching, even meter reading, requires an individual to go out into the switch yard, go out to the actual physical infrastructure, or walk to your premise in order to understand and to read how much usage you've had. Another key issue with the way the distribution system is designed today is that customers only get to see their electric usage in arrears, and they get to see 1 month view of it in arrears after the fact. And so understanding how their behavior affects their electric usage and bill is very difficult for a customer to see with the way the system is designed today. On our side, we also don't get visibility into real-time energy usage at a customer premise and at points of peak demand, and so that creates challenges in terms of helping us to understand where the areas of risk and potential capacity issues will be in that system. Another challenge with today's system is that it's really not designed for bidirectional flow, meaning it's designed to flow as that picture illustrated, power coming from a generator through the transmission system and then to the customer through the distribution system, one-way power flow. And so considerations around distributed generation and other sources that would bring power into the grid from not a traditional source like a gas or coal or nuclear plant, it creates unique challenges to managing the operation of the grid and the reliability of the grid. And then lastly, the way the system is designed today is that there really isn't any clear communication path that a customer can have to get information from the electric market overall. So if there were the ability to get information to a customer about when power was at peak demand and when prices were extremely high as a result of that, there is no communication capability intrinsically designed into the distribution system of today. So let's go ahead and move to the next slide. So taking into consideration all of those challenges with the distribution system, if we were to design one today, how would it look? And fundamentally, what we would have is an interconnected, fault-tolerant, automated, and resilient grid that is visible not only to the central control center, but also to customers, and would be able to withstand single points of failure. So key changes and differences in the distribution system of tomorrow versus today is sensors on the lines that give us real-time information about what's happening with power flows. Two-way communication between devices on that network and a central control system. Two-way communication with our customers. Meters that have remote service switches, meaning we can control power flow at a meter level from a central area. Being able to control voltages and fluctuations and changes in customer power usage in order to address reliability as well as total energy supply required on the system. And a much better integrated back office system that will give us analytics and visualization and information about the way power is used. Let's go ahead and go to the next slide. So always preferring a picture to words. This is another illustration to kind of show what that model would look like in a fairly simplified way. So around the outside, you see the key stakeholders. You see the central control center in the top left, which is the utility operations. You see the transmission control center right below that. On the top right, you'll see what's represented as the market, so the power grid and the signals around what's happening on the power grid, the price of power, and the demand profile. And then at the bottom right, you see the customer. Now, connecting to all of those pieces and parts is the distribution and transmission infrastructure that allows not only do you see two-way arrows between that kind of cloud of infrastructure and all of those stakeholders, but then you also see components reflected in here like distributed storage, which can help with not only resolving power issues and intermittencies on the grid associated with either outages or with renewable and variable power sources like wind and solar. So storage and batteries can provide that type of voltage support and reliability to help manage those issues that renewable power can create. You see the distributed generation there, so if a business or an individual wanted to have a self-supply option local, have the ability to interconnect that into the grid to support that customer as well as provide power back into the grid for other consumers. And then at the customer point of view, you see all kind of a hodgepodge of different technologies there. You see both the renewable energy source, you see an electric vehicle, and again, the key is the two-way arrow between the customer and all of the other stakeholders where they can get real-time information about what's happening with their energy consumption and give them information to make decisions based on that. So let's go ahead over to the next slide. So there's definitely some clear benefits that you could envision as a result from the smarter grid. And as you look at the different types of technologies, we have customer-facing technologies, which examples of that would include automated meters, as we talked about. Now there's two kinds of those. You have automated meters that kind of give you a one-way information flow. So what it does is it kind of pushes, hey, how much usage has been consumed to the utility company. And so we know through much easier and automated meter reading methods, you know, what kind of usage is going on. But that doesn't provide the two-way flow. So that's where advanced meter infrastructure, or AMI meters, come in. And that enables two-way communications, which allows then a customer to get information from a market, telling them what the price is for energy, or different rates that are available depending on perhaps the time of day or the season, or if there are peak consumption issues, then being able to participate as a demand response participant and be able to lower their energy usage in response to a peak situation, and in return for that flexibility and performance, the customer could be compensated for helping to manage the capacity needs of the grid. In addition, there would be in-home energy monitors that the customer could see all of this information flow through and give them the kind of information they need to make decisions. And so the benefits, you know, from that, you know, from the utility point of view, is it gives us information about what's going on with the system, allows us to optimize our operations and our maintenance costs, and can improve our customer service and our safety performance. On the customer side, it gives them a lot of information to make decisions about their energy consumption. Then there's utility type of technologies, and some of those what you could envision as distribution automation equipment, so automated reclosers and sensors on the distribution grid that tell us what's happening with power flows, so that if there's an outage, we can reroute power and get the lights back on more quickly. Or another example would be integrated volt-var control, something that allows us to boost voltages along the distribution system when there's drops due to either perhaps long distribution circuits, or a customer at the end of a line that draws a lot of power that ends up affecting the voltage levels across that whole line, and that creates reliability and power quality issues. So those technologies would actually be put into the distribution infrastructure, and from the utility benefit, again, we would see optimized operation and maintenance costs, better safety, fewer equipment failures, and reduced energy and demand. And then our customers would experience improved service reliability as a result of those investments. And then the last kind of grouping of technologies in this kind of smart grid arena is those that we consider disruptive technologies. And so some of those would be plug-in electric vehicles, distributed generation, centralized or distributed storage, like batteries. And so what those technologies offer the utility, one, so like on the electric vehicle side, it offers new load growth. It can have the potential to help us meet our peak demand. It can help our requirements to reduce emissions from our power plants. And it can also improve reliability and resiliency of the grid. And then on the customer side, you see benefits in terms of lower transportation costs, again, improved reliability, reduced emissions, and potentially more energy independence. So all benefits, I mean, there's a lot of commonality among these benefits related to the cost of operating, maintaining the equipment, and the reliability of the system in doing so. And so then let me just close up by sharing a little bit of information about what we've done here in AEP Ohio. So back in 2008 and 2009, when the American Recovery and Reinvestment Act was passed, the Department of Energy sought projects that would help to advance the capability of the smart grid across the United States. And AEP was one of 10 similar type projects that took a very broad look at different technologies, both disruptive, the customer-facing and the utility-facing technologies, and deployed it in a small pilot area. And so the area we selected was northeast central Ohio, around the Columbus area, about 110,000 or so. It's increased maybe to be about 125,000 or so today. But that demographic from a income and from a ethnicity and from population density, represented a cross-section of the United States in such a way that there was really good data that would be available in putting in a lot of the different types of technologies that I talked about earlier. So we went ahead and with partial funding from the Department of Energy and support from the Public Utility Commission, put in a demonstration project that incorporated many of the technologies I talked about. So in-home monitors that allowed a customer to get real-time pricing information and select different rate structures that were either time of day rate based or seasonally based. We had direct load control where the utility could actually control how much energy was being used by an air conditioning unit in a customer's home if they allowed us to do so. And so all kinds of in-home type programs that the utility and the customer both had information about what was being used and consumed. We also put on distribution automation onto about 80 circuits in the system. We put volt-var controls onto another 17 circuits. We have done some piloting around community energy storage, small batteries actually deployed near customer sites to help manage reliability and supply. And we also had some concentrated electric vehicle deployment throughout the system. So this was a fairly long project, about 42-month deployment and evaluation project in total. Right now, where we sit today in 2013, all the technologies have been deployed, and we are evaluating the efficacy of those technologies. And then based on that feedback, we'll be coming back to the Public Utility Commission with some recommendations on how we think we should proceed in the next stage of investment if it makes sense. So that wraps up my initial comments right now. If there's any questions or anything related to this, I'd be happy to address them when we get to that stage. So I'll turn it back over to you, Michael.
Thank you, Pablo, and thank you to all our panelists today for sharing their insights and giving us a very comprehensive overview and exchange on transmission distribution issues currently, both in the natural gas and electricity arena, as well as some of the forward trends and some of the technology options that may be under consideration either for supply or for the grid in planning for the future. Our program now allows for a question and answer discussion period of about 15 minutes, and questions are coming in from our audience. And why don't we kick off with maybe a question that centers on capital spending and rates associated with transmission and distribution. What caution do our panelists see with capital spending and rate making for transmission and distribution? Some of our speakers have noted the importance of timing and staging investment. There's certainly a federal-state interface and cooperation here as well in managing rising prices, limitations of customers, and the interplay of federal and state regulation. What caution do you see there, and how can we manage those questions effectively for the vantage point of the grid and the infrastructure in the state, but also with sensitivity in terms of the customers we serve? Chairman Sniffler, you want to start that question briefly?
Sure, I'd be happy to take the first swing at that. I think we're already trying to deal with questions that we face by, of course, being a part of the 14-state PJM region. We're dealing with some of those questions as we look at how transmission solutions are implemented and put through their queue process, what that means with regard to costs for the transmission upgrades that are necessary both for system reliability but also to eliminate congestion or areas of the state that are congested as a result of power flows. And so we're seeing where there is a substantial uptick in the amount of transmission projects. Those are regulated by FERC at the transmission level, and so it's a different pricing mechanism with a different rate of return calculation that FERC does. And so that portion of the bill is, of course, then passed on to ratepayers at the state level. And roughly, it's 7 to 10% of the bill. We don't know what that number will look like depending on what projects are ultimately approved and how those costs are allocated as a result of FERC Order 1000. And so we are actively advocating both at FERC through our active cases that they're dealing with, as well as trying to make sure that we're working closely with our utilities in order to understand how they intend to approach the solutions that exist and what that impact may be on ratepayers.
Pablo, you want to add some insights from your perspective?
Yep, all great points. And, as we look at it, all of the things that have been talked about, throughout this webinar are creating, I think, a perfect storm of challenge around T&D rates for consumers. So you've got a significant investment needed in order to address fuel switching from coal to natural gas. You have the potential for investments required around renewable and energy efficiency investments in the system, which have societal benefits of their own. And then on top of that, you've got the need to connect all of those types of sources of energy into the grid. So you've got a significant investment in transmission required, which, as Todd alluded to, it comes through the PJM process and define that the investments needed at that level. And then you've got the core infrastructure and the reliability concerns that I spent some time talking about. And so in the D system, you have your core investments and the potential to make more investments as well to help improve the quality and caliber of that distribution system through a smart grid. So you've got this kind of perfect storm brewing of investments needed across the energy infrastructure, and it's going to be coming to roost right at the doorstep of Chairman Sniffler and his peers around the country in the form of potentially growing rates. And so it's very important to consider the economics from the customer point of view as we consider the benefits that customers will experience from these various investments, as well as the potential benefits on a societal level. So there's a lot of moving parts in this. I think there's a lot of risk that is growing as a result of the changing conditions in the energy infrastructure.
The next question, thank you, Pablo and Todd. The next question I'd raise with Dr. Schlesinger, and we're enjoying a current stable, less volatile pricing regime for natural gas. What happens if natural gas is no longer cheap, and what is going to be the impact of that going forward on the environment, on these transmission and distribution strategies and investments in renewables, in our new power generation strategy? And from your vantage point and experience, what are the best risk management strategies or devices to manage that potential uncertainty, that volatility?
Thanks, Mike. Yeah, this is a great question, and we do get asked this quite a bit. Just one point on the previous conversation. What we try to do, it's kind of the hope, and I know both Pablo and Todd are aware of this, but just to underscore, when you have large new industrial gas-using facility or a large new power plant that uses gas, the hope is to design the system. Of course, the final delivery leg is going to have to be paid for by the new user. But our hope is to design, the system, infrastructure improvements in a way that everybody can benefit from. We hear we see this play out in a number of projects that we've worked on as fuel supply advisors. And it is possible, and it's something that you try to make happen so that people don't wind up paying more as new users come on, but they wind up paying less. I know it's a little bit like a poker game where, everybody, our former boss, Bud Lawrence, used to say if they had a poker game and everybody, one old guy would say at the beginning of the game, if we all play our cards real conservatively, everyone can end up winning just a little bit. Now, I know that's kind of a zero-sum game, so that's impossible. But with respect to new energy infrastructure facilities, it may be possible, and as long as we try hard enough to make it so. In terms of the commodity risk, well, I think, first off, prices are going to go up. That's going to happen. Prices tend to go up when production goes down and demand is high. We're on a long, flat part of our supply curve, as I mentioned. So there's no need for prices to go up as long as there's adequate drilling. But to keep the drillers out there, the price has to go up. So it's kind of a circular thing. In terms of managing, price risk, as you look out on various forecasts, and of course the futures market all suggest that while there will be a price increase, it's not going to be all that much. Maybe it gets up to levels of an average of $5 over the next 10 years. That's the total price, not just the increase. So we're not, we don't foresee, kinds of large increase. And of course, this has had a deleterious effect already on the profitability of renewable energy. And all hope is that renewable energy industry, particularly wind and other solar and geothermal, able to develop facilities and strategies and technologies to reduce the initial capital cost. And I think it's been a real challenge for them. And I think we've been seeing this. Clearly, they're going to continue to need some kind of help, either through the kinds of programs that Todd has been discussing, or federal programs. And I think, again, commodity risk is always, price risk is always there. It's there with oil. Gasoline prices could come down, they could go up. Best to focus on investments to try to reduce that kind of risk, a la Southwest Airlines, that reduced its commodity risk of jet fuel simply by hedging forward when other airlines were having problems. I hope that kind of addressed a couple of the questions that you had, Mike. Thanks.
The next question kind of builds from our audience on another critical commodity here, and that is water. And the question kind of centers on building, I think, on Chairman Sniffler's presentation of balance, portfolio approach in terms of strategies here. The important balance in the environmental choices that we're also making, in particular the water impacts associated with different power generation strategies, and then also independently the water choice consequences that we're also making associated with the development of our fracking resources, our natural gas and liquid petroleum product resources within the state. Chairman Sniffler, you want to comment or provide an observation on that question to our audience?
Sure. I'll take it in two parts. The first one being, of course, there's the 316 issues that we're dealing with water at power plants that has the direct ability to impact operations for power plants, and that certainly causes the power generators some concern as they look at how they'll have to deal with what is a new target with regard to water use. And I think that there is the opportunity for us to find a workable solution, but that, in addition to the air issues, certainly adds to the pressures that mount on generators to be able to provide the electricity and the power that is needed, and that has the potential to add costs. So not just natural gas issues, but electricity issues. These are inputs that will have virtually no place to go but up with regard to cost. Secondly, with regard to development of the shale, I think we're starting to see innovation take place. We're seeing, I think, Ben mentioned the dry fracking that is being experimented with. There's also the use of other alternatives, including propane and carbon foam and other things that entities are looking at in order to find ways to cost-effectively and environmentally safely gather as much of the resources they possibly can, and I think we're seeing that. We're also blessed in Ohio with having a readily available supply of water. And in fact, we have some water companies that are interested in supplying water to some of the companies that are doing the development of the shale play. And so at present, we are in a good position to address it and to deal with the issues. Companies are trying to find ways to recycle water because it's cheaper than having to secure additional resources all the time. And I think we also have to keep in perspective the amount of water that's used in Pennsylvania for 1 year's worth of well drilling was less than the amount of water that was applied to golf courses. So I think we need to be mindful of it, but we also need to keep it in proper perspective as we look at ways that we can develop the resource and ensure that we have readily available supplies. But I think certainly the water issue from the two different angles is approached in two different perspectives and have really two different solutions that are going to have to be evaluated and applied.
Let's go to the next question. Pablo, in your presentation, you made a very useful observation about the shift in managing the systems and the imposition of equipment failures being a critical source of outages now exceeding weather events or emergency conditions. I want to give some more insight on that question and some of the company's strategies on that issue going forward.
Sure, Michael. That's a great question, and it really probably one of the core focuses for a distribution-oriented utility company. So, we see, the reliability opportunities through a lot of different lenses. You don't want to be putting back into the system the same old infrastructure that is falling down today that's, 50 years old. There's clearly a lot of opportunities to incorporate some of the newer technologies and the advances that we talked about in smart grid components into the traditional investment and reliability in the infrastructure. And so what we're looking at now is rather than having necessarily kind of a smart grid program is, utility companies are now looking at how do we embed smart grid technologies into our ongoing management of distribution infrastructure, and how do we do it in a way that is economic and provides the most value to customers. And so it's really it's a cost-benefit calculation, one that we're all fairly used to doing, and something that our regulators and customers expect us to do. So there's I think there's a lot of opportunities to take advantage of where current technology is now in order to make those kinds of investments, and we're putting plans in front of our commission to say, look, we think that with this level of investment, we're going to see this level of reliability, and so there's a lot of transparency and a lot of visibility into how these various programs are working, whether they're traditional vegetation management programs or if they are specific infrastructure and asset replacement programs. There's a lot of visibility and transparency as to how effective those investments are being made, and the numbers will have to speak for themselves. So great question, and one of the key issues facing us utilities today.
Before we wrap up our question session, one final question, I think, for all the panelists. We have several questions from our audience that really focus on the gas-electric interdependency issue. A number of our panelists have spoken to this in their formal comments. In our work at the school, that really raises four main areas it seems to address. That's resource adequacy, the interrelationship of gas supply with capacity to meet demands for needs on the grid and for power generation. Secondly, how this is done with reliability and sensitivity to that concern. Thirdly, as Chairman Sniffler noted, operational questions, planning, procedures, protocols that arise between the industry. And then finally, policy issues. What policies maybe don't work that need correction going forward. Each speaker conclude maybe with a minute or two comments on that question, and what we can look forward to and what needs to be achieved to address and make the gas-electric interdependency issue more effective and better. Ben Schlesinger, why don't you start?
Sure, Mike. I think, each situation is completely different. Each power plant, in grid, has its own unique issues. We've discussed this already in a couple of ways, so I'm not going to add too much, but I would say one thing that we probably haven't talked about that plays into this is gas storage. If there's a way, for example, one project that we worked on is right near an LNG storage facility. This is a way to dispatch gas to the plant without a lot of concern about whether the pipelines, pipeline nominations a day ahead and that kind of thing. Also, the mixture of resources, a good, healthy mixture of resources to generate electricity is, is a wonderful way to advance, make gas electric interdependency easier. And then finally, if there were a smart grid of the kind that Pablo's been describing really successfully, boy, this could sure help. Even battery electric vehicle, storage, other forms of storing electricity, I think could really go a long way. Over to you.
Pablo, your last thoughts on the gas electric interdependency issue, and then Chairman Sniffler to conclude.
So, two quick points. One is that, as Ben brought up the storage issue, one of the concerns that I see is around adequate transportation resources in order to be able to provide firm contracts and firm supply for gas plants that today are running like baseload generation rather than more as peakers as they have in the past, need to have the ability and the infrastructure to not only, of course, have the gas itself, but to get it through the transportation system and the transmission system to those plants. So that's one key issue. We can't lose sight of how much infrastructure investment is needed to make sure that the supply is available. And maybe the last point is just quickly that, we have to I think, be cautious and be prudent in terms of how we think about the resource mix in the future. And too much of a good thing can sometimes be a bad thing. And so having a very broad-based fuel supply that incorporates an all of the above strategy of gas and coal and nuclear and renewables is one that's going to, I think, serve the country's interests best and certainly Ohio's interests best.
Chairman Sniffler, the final comment on that question.
And I think I would echo the comments that have already been made. I think the infrastructure is going to be one of our major issues in dealing with it because of the way that pipelines are constructed, and the basis upon which they're constructed is not a cost recovery method that traditional regulated utilities would use, but it's based on customer demand when they're going to extend pipelines. And so we're going to have to look at how to address the pipeline infrastructure question, as well as the prudency test that I talked about with regard to firm contracts. And ultimately, it's communication, and it's how are the entities going to communicate. And really, depending on where you are in the country, it's going to depend on how the RTO or ISO or the balancing authority is really working on trying to address the issue. If you're in New England, this issue is crucially important, and they're glad that spring is here as they're about to escape what could be a very difficult period of time for them. If you're in the southeast or in the northwest part of the country, it's maybe not as big an issue. And if you're in PJM, where we're located, it's becoming an issue, and we're trying to be proactive in dealing with them, both, as I mentioned, at the NARUC level, but also here at the state level, because ultimately a lot of this is governed by FERC authority. But as a state regulatory body, we certainly want to be engaged in the process and be convening entities to come together to discuss the issue and make sure that we're working on solutions that can help address really some of the granular technical issues that have the ability to trip up and cause some of the larger overarching issues. And we've already commenced work with that, and we're going to continue to be very active in that space between now and when we work on a regional and national solution towards trying to address this overarching issue.
Thank you to all our panelists this afternoon for the gift of their time as well as their presentation. I think we've seen the importance of the transmission distribution issues and planning state infrastructure for the future in Ohio, as well as the broader region in which we serve, the coordination, the environmental benefits associated with those choices, and the importance of cost management and reliability in that process as well. I'm pleased to turn the program back to Alyssa Welsh with Ohio University. Without Alyssa's fine work in staffing both the grant program as well as this webinar today, this program could not have been offered for the benefit of the citizens of the state as well as nationwide. Alyssa, the floor is now yours.
Thanks for the kind words, Mike. Just wanted to say on behalf of the Ohio University Voinovich School, I wanted to thank all of our speakers and participants again for joining us today. As we mentioned at the start of the session, it's our intent to post the recording of this webinar on our website at www.ohio.edu/CE3 in the coming days. Tomorrow we'll be sending a reminder email out to all the participants with a link to an online evaluation for the webinar. Please fill this out to help us plan for additional energy offerings that we're going to be extending this year, and we certainly welcome your input and ideas for suggestions on future energy topics. Thank you again for joining us today, and enjoy your day.